Given that tan x equals to root 3 and x lies between 0 and 90 degrees, the question asks is to evaluate cos square x minus sin x all over sin x square plus cos x. So this is what we are asked to find the value of this. But if tan x is root 3 and x is an angle between 0 and 90 degrees. So let me attempt to answer this question. Solution to that, what I will do first is to sketch a right angle triangle. The triangle that I have applied the trig ratio, that it is tangent of the angle at x, or the tangent of angle x is root 3. So let me attempt to sketch that. If this is the triangle, this is the angle x. Tangent means opposite over adjacent. Opposite over adjacent. The tangent of x is root 3. So I have the opposite side to that x will now be having length equals to root 3. And the adjacent is now 1, because root 3 is nothing but root 3 all over 1. Then I can now find the longest side, which is denoted by letter y, the length of that longest side, using Pythagoras. So I can get y to be equals to root of square of this side plus the square of this side. Square of root 3 is nothing but 3, and square of 1 will be nothing but 1. So I continue, I'll have 3 plus 1, root of 3 plus 1, and which is equals to root 4. And root 4 is nothing but 2. So the length of the hypotenuse, which denoted by letter y, will now be equals to 2 units. So I can now obtain my cos x and my sin x, because I have all the 3 sides of the right angle triangle. So starting with cos x is nothing but the adjacent divided by the hypotenuse. The hypotenuse is y, which we have as 2, and the adjacent is 1. So cos x is nothing but 1 over 2. Then I will get the sin x, because I have it in this formula. So sin x will now be equals to opposite divided by the hypotenuse. Opposite is root 3, hypotenuse is 2. So sin x will be root 3 all over 2. So I can now substitute cos and sin in here. So cos x square minus sin x square all over sin x square plus cos x square is what I'm trying to substitute now. Cos x alone is 1 over 2, but square of it. So I have 1 over 2 whole squared. Side x is root 3 all over 2, so I have root 3 all over 2. Look at it. I'll come down. Sin x square, sin is root 3 all over 2, but it is raised to the power of 2, plus cos x is 1 over 2. So down I'll have root 3 all over 2 whole squared, because of the square here. Then plus 1 over 2 instead cos x. So I continue. Simplify numerator. 1 over 2 whole squared is nothing but 1 over 4. Then minus root 3 all over 2. So I have 1 over 4 minus root 3 all over 2. The LCM is nothing but 4. So I rewrite it in this format now. 1 over 4 is this 1 over 2 whole squared. And this square also root 3 all over 2. Root 3 square is 3. And 2 square is 4. So I have 3 over 4. Then plus this one. So let me tackle this. So simplify this bracket, then this bracket. 1 over 4 minus root 3 over 4, the LCM is 4. So if I have it, I have 4 here as the LCM. So 1 minus 2 root 3 all over 4, this division. Then adding 3 over 4 and 1 over 2, I have 5 over 4. So I'll continue dividing this by 5 over 4 is nothing but multiplying by 4 over 5. So if I multiply by 4 over 5, I'll have 4 cancel 4. So I'm going to have 1 minus 2 root 3 all over 5. This will now be the final value of this cos x square minus sin x square divided by sin x square plus cos x square plus cos x. I beg your pardon. So with this, I have answered this question. So let's see the mark distribution according to the Waec marking scheme. The mark distribution for this, the first mark is the bonus 1 mark, and this bonus 1 mark is for getting cos x as 1 over 2 and the sine x as root 3 all over 2. The two must be correct before you are awarded this mark. Cos x 1 over 2, sine x as root 3 all over 2. Then the next mark is the method mark, is for substituting your cos x and your sine x in the formula or in this. Then the last mark is after you simplify to the final stage and you have the value as 1 minus 2 root 3 all over 5. You have the accuracy 1 mark. So in total, this question 3 marks are allocated to it according to the Waec marking scheme.